Good morning, students. My name is Muthazhaghu, Chief Engineer from Marine Engineering Department. Last class we had seen crankcase explosion, main engine crankcase explosion. This class we will see about the crankcase oil mist detector, which will alert you or give the visual and audio alarm and stop the engine or slow down the engine when there is a condition for crankcase explosion. This is called crankcase oil mist detector, and this what is shown in the diagram is gravinal oil mist detector. This is used in two-stroke engine, that is slow speed engine. What it does is it got a exhaust fan. It sucks the air or vapor from each unit through the rotator, which will allow at a time one unit to the tube. It consists of your exhaust fan and two lens, one lamp, and two mirror and two photo cells, and it got a measuring tube and reference tube. What happens is when engine is running, this exhaust fan will run continuously and it will suck air from each unit. From each unit, one copper tube will come and connect to the rotator, and according to the rotation, when engine is running, the rotator will connect each and every unit one by one, and not only that, it will connect outside air also one time, so that you can zero compensate your instrument. You can zero correct the instrument. So what happens is it sucks from one unit and that comes to the measuring tube. All other unit, whatever comes from there, it goes to the reference tube. So it goes to the tubes. So what happens is the lamp, which is placed in front of the fan, will send the rays to the mirror. Why we have one lamp and two mirror means because we don't want to have separate lamp and separate mirror. Maybe the lamp density may vary, so we use one lamp and two mirrors, so the light rays are reflected through both the tubes. So according to the mist or according to the vapor concentration, the amount of light falling on the photo cells will vary, right? If too much mist, that intensity for the measuring tube will be less than the reference tube. Then, so it is connected to the reference circuit on an electronic circuit. The difference is compared to a potentiometer, where its set point, which if exceed will start alarm. So usually it's connected to the electronic circuit, and then the difference is compared to the potentiometer, which is set point. Just a set point. If the set point is set point is reached, it will give a alarm. So when it gives the alarm, what happens? The rotator will declutch and it will stay in the unit from where this vapor is coming. So immediately it will give an alarm, it reduce the engine speed. So once you come and see the OMD, you can see which unit it stopped. So you can see maybe number 1, number 2, whichever unit. Do one thing, you don't know whether it is right alarm or wrong alarm or false alarm. So what you have to do is go to that unit and just touch the crankcase. If you feel it is hot, then it is a right alarm. So immediately you have to inform the bridge, you have to stop the engine, and then you have to wait at least 30 minutes before opening that unit to check any hot spot. So this will give the alarm much before any mist formation which is going to reach the firing point. So this way it gives alarm, it will let you know there is a condition inside the crankcase which is going to lead to a fire. So because this takes the vapor from the unit and use the long tube, this unit is not always 100% right, because some of the time these tubes coming from the unit may get choked. Then also it will give the alarm, or your lamp intensity has come down, or your mirror is gone, or your lens are dirty. Then also it gives alarm. So whenever you get the alarm, first make sure it's a real alarm. Otherwise, if it is a false alarm, then what you have to do is you have to overall the oil mist detector, then we can proceed. But don't ever stop the oil mist detector. If it gives false alarm, then you are putting main engine in danger. In modern ship, you can't stop the oil mist detector, because once you stop the oil mist detector, your engine won't start. So this is for your two-stroke engine. And for high-speed engine, we have a later development. Because of the development in technology, we got UV light, rank is light scatter. What it does is, here each unit will have a unit which will send the UV rays, and it will have a detector also. So what happens is, light source goes to the your unit, and if the oil is there, nothing will happen. If the mist is present, then the density will reduce. Immediately it will raise alarm. All this are this each unit is connected to your CCU computer, engine computer, and there it will show your real reading. When engine is running, you can see how much the intensity in this. So it will keep on measuring continuously when the engine is running, and it is very fast. It will send the signal very fast because it is all electrical. So this, when the signal comes, immediately it will raise the alarm in the engine room and engine control room, and you can see in the computer or monitor which unit which gives a red light. Immediately you can take action. Only thing, this is very fast. We can use, nowadays we use this for medium speed engine and high speed engine. This is possible because of the latest development, and this unit got its own address which is fed into the computer, and then straight away it goes to the control room monitor. There you can monitor this continuously. So this is latest development. And otherwise you will have that Graviner oil mist detector. This we use it for four-stroke engine also. This light scatter mainly for medium speed and high speed engine. Thank you.